Thank you. Thank you. Thank you very much. Uh-huh. Yeah. I'm the king.
Man, I'm getting pretty good at this. Oh, sorry, I didn't know we had started. Hey, everybody, welcome back to another episode of Math Video. This is Mr. Haugom here, just letting you know that I'm actually leaving the teaching profession to actually become a mathematical performing Elvis impersonator. Yeah, I'm going to try and help rejuvenate some of the King's lesser remembered albums. But before I go, I think maybe one more lesson I could muster up. This episode will look at the Quadratic Formula. Enjoy! And in this lesson, we'll be taking care of business in a flash.
Thank you. Thank you very much.
Oh, the 60s and 70s were such a great time for music, and we all know and love and appreciate all of Elvis's #1 hits that were mainstream. But it was this collection of albums that Elvis was most proud of, his mathematical collection. He was obsessed with math. Actually, he was known to run off stage and solve a few equations in between sets during his concerts. The girls in the crowd used to throw compasses and rulers on stage to show their adoration. It was unbelievable. However, the music industry put such pressure on Elvis to stop singing about math that it drove him crazy. It actually led to his demise. He lost it. He just felt so heartbroken that he couldn't sing about math that was it. So it's my goal here today to breathe life back into albums like these, to bring back the love of mathematical music.
Thank you. Thank you very much.
So I think we can all agree that I got the Elvis voice down. It is spot on. And I'm set with all the Elvis apparel. I got the wig, the awesome jumpsuit, and those sweet, sweet blue suede shoes. But on second thought, this might be a little too 70s. I kind of like the 60s look with the clean-cut suit. Yeah, I think we'll go that route. Now I just need an idea for a song. I got it.
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's how you find the x-intercepts of a quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's how you find the x-intercepts from a quadratic equation.
So let's get into the use about the quadratic formula. So let's remember that quadratic relationships are all about parabolas. And remember that those important x-intercepts help find our line of symmetry, which eventually leads to our vertex. And don't forget, when these x-intercepts are sitting down on the x-axis, that means their y-coordinate has to be 0.
Thank you. Thank you very much.
Let's look at another example of a parabola and its factored form equation and see how we can find the x-intercepts from only using the factored form equation. So if the x-intercepts are on the x-axis, that means their y-coordinate is going to be 0. And there will be two different ways that I can make this equation be 0. I could make this first parenthesis group become a 0, or the second parenthesis group, make that be a 0. And anytime you multiply with a 0, either this group or this group, it's always going to make the entire equation equal to 0. So if we plug in 4s for the x position, you can see that the entire equation will become 0. So that makes this x-intercept 4, 0, which corresponds to this one right here. And the other way that I can make the equation equal to 0 is by choosing the number 8 to go into the x positions. And therefore we get an x-intercept of 8, 0, which corresponds with this x-intercept point right here. And now let's quickly find the in-between, the middle of our two x-intercepts, which would be where our line of symmetry is. So a fast way to do that is just to average those two. Take 4 plus 8, divide it by 2, and we get our line of symmetry at 6. And if we quickly want to calculate what the minimum point would be here on our vertex, all we have to do is plug in the 6 into our equation, and that will tell us where our minimum point is, because it will be exactly when x is 6. And there we can see that our vertex, our minimum point, is going to be at 6, -4.
Thank you. Thank you very much.
So what does this have to do with the quadratic formula? Well, let's just say that this factored form equation was turned into an expanded form equation instead. And now this equation is in the standard form of y equals ax squared plus bx plus c. And what comes next? You guessed it, we just use the quadratic formula. We start plugging in our a, our b, our c into the formula, and it will give us our x-intercepts for us. Oh, I'm so excited to see this in action. You guys must be too. So the a number is the coefficient on the x squared term, and you can see that there is no number here, so remember we can use a 1. The b number is the coefficient on the x term, in this case it's a -12, and the c term is the constant number, which in our equation is 32. So let's start plugging away. X equals -b, or the opposite of b, so seeing our b term already is negative, a negative -12 is kind of like having a positive. Plus or minus the square root of b, again, minus 4 times a times c, all divided by 2 times a. So let's just start simplifying. The bottom here is going to be 2. Now we'll start to simplify underneath the radical, and in quadratic formula speak, this is called the discriminant. So in here, this is going to simplify to make positive 144. And we'll take away 4 times 1, which is 4, and 4 times 32 is 128. And 144, take away 128 is 16. And the square root of 16 is going to be 4. So now I just got to solve these final steps 2 different ways. One way I'm doing the 12 plus the 4 and then divide by 2. And then the other way is to do 12 minus the 4 and then divide that by 2. So now we have that set up here. So 12 plus 4 is 16 divided by 2 and we get 8. And 12 minus 4 divided by 2 and we get 4. So what does that mean? That means our x number is 8, so 8, 0 is an x-intercept, and the other x number is 4, so 4, 0 is the other x-intercept. And lo and behold, that's exactly what we found the first time with our x-intercepts with the factored form. So again, after finding your x-intercept points, you could find your way to the middle, find that line of symmetry, and find your vertex. We could plug that number 6 into either one of these equations here or here, and we could then find our vertex.
Thank you very much.
So the last thing we want to talk about is the discriminant in these quadratic formulas. So after simplifying underneath the radical, if the discriminant here is going to give you a, in this case, like a perfect square number, whole number, or it could be work out to be a decimal number, that means you're going to have 2 different answers when you do 20 plus that number or 20 take away that number and then divide it by 4. You're going to come up with 2 different answers. So in this case, you have 2 solutions. Down here in the red example, if the discriminant after simplifying it is 0, that means there's nothing to do here. The square root of 0 is 0, so adding or subtracting 0 from this, that's not going to change anything. You're only going to have 1 answer when you're done doing the division. So this has 1 solution, or 1 x-intercept. And the bottom example in orange, this one is very different. If your discriminant is a negative number, here's where we have a mathematical impossibility. The square root of a negative number, there is no way I can multiply any number times itself to make this negative number, so we can't do it. It's impossible. So this one would have no solutions, which means there are no x-intercepts for this parabola using this quadratic formula. Well, congratulations, you are all now experts in using the quadratic formula, so I guess there's only one thing left to do, and you know what that is.
X equals negative b, plus or minus the square root of b squared minus 4ac all over 2a. And that's how you find the x-intercepts from a quadratic